There can be labels on the vertices, and there can be labels on the edges. And in many cases, graphs very naturally describe your data you already have. For example, the Facebook social graph, where the vertices are the Facebook users and the edges is friendship between users. That data comes in the form of a graph. And the graph database is one which is able to store graphs. But the crucial point in my eyes at a graph database is not that you can just store graphs. You can store graphs in a relational database using two tables. You can store it in whatever data model. The crucial thing for a graph database is that you can do graphy queries. So what's a graphy query? Well, in graphs, you are interested in the connectivity. And I call a graphy query one where you do not a priori know how long the paths you are looking for are. Because whatever data model you do, if the database is not prepared to that, then it will suffer with respect to performance. For example, in a relational database, this leads to nasty multiple joins, which are not known a priori, which totally kills your performance. So the crucial thing in a graph database is that these type of graphic queries like graph traversals, shortest paths, and so on are implemented in the database server with special routines. Okay, I've shown these three, and there's a reason why I mentioned these three and not others. We'll come to this in a second. I want to introduce or show you the idea of polyglot persistence. Because now that we have multiple data models, a very near idea is that you persist